Good evening, everybody. Welcome back to this weekly course, weekly session on graphs and data science. So I understand that that many new students have enrolled. So I think many of you are attending these sessions for the first time or maybe for the second time. But even if that's the case, even if it's the second time, you would have missed the course overview, the introduction to this course, which I gave about 4 weeks ago. Okay. So what I'm going to do right now is give you, an overview of the course for the first 10 minutes. So before I start the new topic, which is module 2, I'm going to give you just a quick overview of the course. Okay. For those of you who were here from the beginning, this is stuff you've already seen before. There's nothing new. But for those of you who joined after the first week, I think it's good for you to just get an overview of this course. And as you'll see, the second module of this course, which I'll be starting today, is a fresh new module. And so even if you missed the last 4 weeks, that's totally okay, because each module is independent in terms of the prerequisites. Okay, you don't have to know anything from the first module in order to do the second module. Okay, so all right, so let's get started here. So this course here has 3 different modules. The first module is on link analysis, and we did this the last 4 weeks, and the question that we looked at was when you enter a query term into the search engine, such as Google or Bing or one of these many search engines, there are millions of web pages which contain your query terms. And how does a search engine choose the most relevant web pages to show in response to a search query? So you know that when you enter a query term in the search engine's homepage, that when it displays the results, quite often the most relevant web pages are listed at the top of the search results. Maybe very rarely, you might have to go to the next page and look at another 10 more results. But often in the first tens of results, you end up finding what you are looking for. In fact, quite often you end up finding what you're looking for in the first few search results. How do they do that? And they use the link structure of the web graph. They run an algorithm called the Pagerank algorithm. Well, that was the original algorithm, the Pagerank algorithm. And they run that algorithm or an algorithm similar to that one, which takes into account the link structure of the web graph in order to decide which web pages are the most relevant or the most important. The second module of this course is the one we're going to be starting today. So the first module had 4 lectures. Right now we're at the 5th week. And so this is the beginning of the second module. The second module will have just 3 lectures, and the third module will have 3 lectures. That's a total of 10 lectures. Okay. The second module is on advertising on the web. So what happens is today, many services and many internet companies are offering their services for free. You don't have to pay anything to use the Google search engine or to use Facebook and so on. And that's because they make a lot of their money from advertising revenues. So along with the search results, they also often display advertisements. And if you click on those advertisements, then the advertising company will pay the search engine company some money. And that's called advertising revenue. And from this advertising revenue, which the companies collect, which the search engine companies collect, they make a lot of profit. The thing is that there are many companies that are competing to have their ads displayed. So when there are many advertisers, all of them are making bids to have their ads displayed. How does the search engine company decide whose ad to display so that they can maximize their revenue? So this is an area that's called computational advertising. It's another computational problem that search engine companies solve besides the, besides, ranking the web pages. And so we're going to look at that starting from today and for 2 more weeks after today. The third module in the course is on mining social network graphs. Given a large graph that represents the connection in a social network, for example, given the Facebook friendship graph, how do we discover communities in this network? So we're going to look at algorithms for community detection in social networks. Now, these are 3 different topics, but there's a common theme that goes through all of these 3 different topics, and that's that they're all topics in data science where graph algorithms are used extensively. So for those of you who don't know what a graph is, or who have never taken a course in data structures or algorithms, that's all right. This course is going to be self-contained. But basically, there are many applications where the problem that you encounter has the structure of a graph. When I say graph, I'll define what a graph is very soon. So for those of you for whom this is the first module that you're attending, you'll know what a graph is. It's not the same as, the graph of a function f of x equals x squared is the parabola. No, this is a different meaning of the word graph. It's basically a bunch of vertices joined by edges, okay? So that's one of the common themes in this course. It's that you have graph data that you have to work with and analyze to make your decisions. And of course, all the problems we'll be looking at are computational problems, meaning that you have some practical problem, some real world problem, and you need to somehow figure out a way to solve it with the help of a computer.